Okay, so we're going to put together slope fields with the solutions for the differential equations, because a lot of times, sometimes we'll see a multiple choice question. A lot of times when you have a differential equation on a free response question, a slope field is part of it. So we're going to start with this equation, dy over dx equals x plus 2. So this is a pretty simple differential equation that we're dealing with here. We are going to draw a slope field for this, and let's just do a 2 by 2. We draw in our slope field here. We've got x plus 2, so all our vertical bands are going to be the same. So at negative 2, what's our slope going to be? 0. Then at negative 1, we'll have a slope of 1. So all of these will have a slope of 1. At 0, we'll have a slope of 2. And then as you go across, everything just gets a little bit steeper. So then here we got 3. And then 4. And just because, I know what this is going to look like, let's actually add a negative 3 over here, just so we can see it a little bit better. At negative 3, if I plug in negative 3 into this differential equation, what am I going to get for my slope? A negative 1. So these will look like this. And that kind of gives you a little, now you can see the picture a little bit better. What's the solution to this going to look like? A parabola. And you can tell this is a pretty simple one to solve. You're going to have a parabola here. Okay. So what we're going to do now that we haven't done yet is find the particular solution that passes through 0, 1. So we have not done this yet, but we've kind of done most of it. We are looking for the solution that passes through 0, 1, which would be this point right here. We have not done this officially with differential equations, but we sort of have done this with some of our position particle sort of problems. So we're starting with dy over dx equals x plus 2. So this is a very simple one to solve. We're going to multiply both sides by dx to get the dx over here, which separates our variables for us. And then we're just going to integrate both sides. So y equals, over here, we're going to get 1/2 x squared plus 2x plus c. Do not forget your c. Usually they're more complicated than this problem, but they love to give these on the free response section. And if you don't put the plus c, you're going to be out of 3 or 4 points that you're not even eligible for after that point. So make sure you've got your plus c. And so if I want the particular solution that passes through 0, 1, I don't want this general form with the c right there. I want to know the exact formula of that equation that goes through 0, 1. So we've kind of done this before where we've had to find our c. So we're going to plug in 0 and 1. So we'll have 1 equals 1/2 x squared, 1/2 times 0 squared plus 2 times 0 plus c. And so that just gives you 1 is your c. So our particular solution is 1/2 x squared plus 2x plus 1. So this is our particular solution. The last thing that they'll usually ask you to do, or sometimes they'll actually ask you to sketch the solution before you find the solution. I like to go ahead and find my solution first so it kind of verifies to me what it should look like. I don't really know how to graph 1/2 x squared plus 2x plus 1 really quickly anyway without doing a lot of work to it. But I know it's a quadratic. I know it opens upward. I know it has a y-intercept at 1, so that gives you a little bit of information. So when we have to sketch the solution, if we go back up to our slope field, we know that that quadratic has to pass through the point 0, 1, because it told us that, plus it's part of our equation. So you're going to draw in a graph, and it really doesn't matter if it's perfect. It just kind of has to fit the lines here. Alright, so you're drawing in something that fits the lines. It doesn't have to be perfect here, but something that looks sort of like this. To give you an example, just so you see like of something that would not work. Like for example, let's say that I was mistaken and I thought that this opened downward. Okay? That would not work because you can see right here, those tangent lines clearly would just cut right across that graph, right? Over here, it's kind of working till you get to like right here where it's going to start cutting across the graph too. But the tangent lines have to follow the flow of that graph. So you're just sort of filling it in. It really might go down a little bit lower. It might sort of go right through here and touch the x-axis at -2. I'm not really sure. But whenever they ask you to sketch a solution, as long as it passes through the point and doesn't go against any of your tangent lines that you have drawn in there, it's okay. So that green one, I'm going to get rid of because it is wrong. There. It can be either. It can be either as long as it's not going against the line. So like another, like if you wanted here, if you wanted it to touch the lines, you kind of do. You'll have to kind of go under a little bit if you want it touching both right there. But as long as it flows with the lines, it really doesn't matter too much there. It does not have to touch each little tangent line there because it probably won't, because we didn't graph every possible slope. We only used the integers, so it might go through the point -2, -1/2. But the slope would still be 0 there. So it doesn't have to touch them, but it just sort of has to go with the flow of it. Okay, questions? I kind of hate doing those because I don't like the uncertainty of it, but generally if you just follow the pattern, you'll be okay. All right, let's do another one that is a little bit more difficult. So we're going to sketch a slope field for this next one. So if we sketch this slope field, what are we going to get anytime x is 0 0. We're going to 0 on the bottom, so that's undefined. So undefined is vertical. Undefined is vertical lines. Notice I skipped 0, 0, because what do you get if you get 0, 0 at the point 0, 0? You get 0 over 0, and 0 over 0 is not undefined, it's indeterminate, so they're never going to ask you to put a point there. Not necessarily. It would depend on the equation for that. Yeah, you're just going to skip it, and typically, like if it is a slope field you're having to sketch on the exam, they typically will, like they'll put dots at each point that you need to put a line at, and they just won't put one there at the origin. So you don't have to put anything there. What about if y is 0? What do we get if y is 0? We're going to get a horizontal line, except for at 0, 0, right? So we get horizontal lines here. And then if we just start plugging in points, like if I've got the point 1, 1, that gives me 3 times 1 over 1, so that's a slope of 3. If I have the point, I'm going to have to start doing a chart. I can't do it. X, Y, dx. So like here's the point 2, 1 right here, so that would be 3 over 2. So it's going to be less steep there. Then I would have the point, let's do 1, 2. So that would be 3 times 2 over 1, so 6. That's going to be super steep. And then I'd have 2, 2. That I'm going to get a 3. So now I should note, like right here, whenever I have like the point 1, 1 and 2, 2, I'm going to get 3 every time for that, right? Because top and bottom sort of cancel. So same thing's going to be true. We're going to get a 3 right here and a 3 right here. And then, like if I have 1, negative 1, which is this point right here, that is going to be negative 3 over 1, so I get negative 3 there. And then if I have 1, negative 2, which is right here, and that gives me negative 6 over 1, so I get negative 6. And then I'll have 2, negative 1, so 2, negative 1 will give me negative 3 halves. Oh, it's less steep than that one. And 2, negative 2 is going to give me negative 3. And we get over here, I think everything's just mirrored right here. So if we do like negative 1, 1, we'll get 3 over negative 1, so we'll get negative 3. Now, I think everything is just going to be sort of reflected over that y-axis there. So I'm going to just go ahead and put those in. Something like this. Okay, so for the last one, our differential equation just had an x. So it didn't depend on the y in this case. So like anytime my x was 1, I knew the slope was going to be 3. So if that happens, it's a good thing for you because that means like your vertical bands are all going to be the same. If it only had a y, then horizontally, all of them would be the same. But whenever you have an x and a y, you've got to do each point individually. Sometimes you can notice some patterns where you can kind of reflect or do something different, but you're going to have to do each point separately when you have an X and a Y. Okay? Questions so far? Now, I think it's kind of hard to see what that looks like here. We now need to find the particular solution through -1, 2. Okay, so we're starting with dy over dx equals 3y over x. So dy over dx equals 3y over x. And we're going to multiply by dx. So we get dy equals 3y over x dx. I need to get rid of that y on the right-hand side, so what should I do? Divide by that y, or the 3y, it really doesn't matter which one. I think I'm just going to leave it on the right-hand side. I think I'm just going to divide by the y here. But you can do either way. Generally, you want these solved for y, so sometimes it's easier to solve if you keep as little with the y as possible. So dy over y equals 3 over x dx. So differential equations, remember, you must separate the variables. If you don't separate your variables, you're not eligible for any points on that section, which is probably like 5 or 6 points. So then you would integrate both sides, and when you integrate both sides, you get natural log of y equals natural log, well, let's see, 3 times the natural log of x plus c. Yeah, they're probably going to have this solved for y most of the time. I didn't specifically say it here. At this point, we could plug in that -1 and the 2 if we want. And really, I guess technically we should have absolute value bars right there. We could plug those in if we want and find the c first, but most of the time they want this equation solved for y. So I usually solve it for y first and then plug in to find my c. So if I want to solve this for y, I need to do e to the on both sides. But here's our problem. This 3 on the outside really kind of messes you up, because if it weren't for that 3, e to the natural log of x would just be x. What can I do with that 3? There's some properties of logarithms. We can move this in here as our exponent. So we've got natural log of the absolute value of y equals natural log of the absolute value of x to the third plus c. And now we can do e to the right here, which will cancel out our natural log on the left-hand side. And remember, I'm going to do every step here. You don't have to necessarily do every step. This is e to the natural log of the absolute value of x to the third plus e to the, oh, not plus, times e to the c, right? Because c is in your exponent, just like we did with our exponential sort of stuff. So this e to the natural log, that cancels, but we have e to the c. What do we do with e to the c? Just make it a capital C, but it's multiplied. So we've got c times x to the third. It's not x to the third plus c. In this case. And so now that I've got it solved for y, it's a lot easier now if we plug in. C is an unknown value, so e to the c is also an unknown value. So we want to keep it as simple to solve as possible. We just replace that e to the c with the capital C, because on the last one we were not doing, like, we did not do anything to our C. On that one, we did the same thing. That's why whenever we did that, we got y equals CE to the KT plus whatever that ambient temperature was. So the same thing happened there. This over here was different. That was not your C. That was your ambient temperature in that case. But the C, the same thing happened to it there. So it was like KT plus C there, and yeah, natural log of y equals that. So when you do e to that on both sides, you get y equals. We weren't writing every step, but we would do e to the KT times e to the C, which would give you y equals CE to the KT. So we were doing the same thing there. We were just kind of skipping steps because we'd done lots of those problems, and they all ended up the same. So when we get this, what number? We've got to plug in -1, 2. -1, 2. So we get 2 equals C times -1 to the third. And what is -1 to the third? -1. So if I divide by my -1 there, C is -2. So my equation is y equals -2x to the third. And so -2x to the third is going to be this kind of doesn't look like anything to me. I have a hard time seeing what it is. But if I graph the point -1, 2, which is right here, I can kind of see now that this could be a cubic function that's been flipped upside down. It sort of fits that, and you can kind of see like more cubics here. I think it's hard to see until you solve that to know what the solution is supposed to be, because there's a lot of, like, it almost looks like sideways parabolas a little bit, not quite, but so this is what you would draw in for your solution. Okay, questions? All right. Let me save these, and I got another problem I want us to do from the part A, because we didn't do part A on these at all. This is fine, because we've really already done a lot of it, but there's a couple I need to do. So you can just add these to your notes in the notes. So I don't think we have to do that. Well, were they not on here? Where'd my problems go? Alright, so let's do this one. Alright, so let's do dy over dx equals y over x squared. And we're looking for the solution through 1, 3. And we won't do a slope field on this one, we'll just solve it. Sometimes they don't ask you to do a slope field, which is good and bad. I don't like them, they take too long to do, but they are kind of easy to do. So what could we, for here we'll have to multiply by dx. So we get dy equals y over x squared dx. And then we need to get rid of that y on the left-hand side. So I'll divide by that y on both sides, which leaves me with dy over y equals dx over x squared. Okay, any questions on your separation? Once we separate, we're going to integrate both sides. What do I get when I integrate dy over y? Natural log of the absolute value of y. What do I get when I integrate dx over x squared? Okay, negative 1 over x plus c. And we get that because we're really integrating x to the negative 2, which is negative x to the negative 1, which is, it's best to go ahead and make that negative 1 over x. I'm very glad everybody said negative 1 over x so quickly, with multiple people saying that, because what I usually see at this point is that kids start doing this. Anytime something is in the denominator, they say natural log of the absolute value of x squared plus c. Alright, you can see how that would be a temptation, because if it is just a number in the denominator, it's going to be natural log. But if it has an exponent, if it is squared or to the third or even to the negative fourth or something, 1/2, something like that, then you integrate the power rule. So be careful with that. So now we're going to do e to the, because these are typically going to be solved for y. So we get y equals, and what's going to happen to this c right here? It is going to go out front as the big C, right? C e to the negative 1 over x. Okay, so here's our general solution, right? So once we've got our general solution, we want to plug in 1 and 3 to find our c. So we would have 3 equals c e to the negative 1 over 1, which is 3 c e to the negative 1. What am I going to do with that? I can't take natural log. I'm not going to take the natural log. I'm trying to solve for this c right here. Okay, e is a number, right? So I'm going to divide by e to the negative 1. Or there's several ways you can think about this. But when I get 3 over e to the negative 1, I don't like those negative exponents. So what is that the same as? Just 3e is your c. The other way you could think about that is this is really 3 equals c over e, right? Because if you move that negative exponent to the bottom over here, then you could multiply both sides by e, and c equals 3e in that case as well. So a couple ways to think about that, but you get the same result. So our equation is y equals 3e times e to the negative 1 over x. Now, I want to show you, like, free response, leave it here. Don't do anything else with it. But let me show you something crazy, because if it's multiple choice, this is probably not going to be your answer. Okay? So, notice you've got 2 e's there. They have the same base, right? So, this e has an exponent of 1. when I'm multiplying things with the same base, what do I do with their exponents? You can combine them by, what do we do? Add, subtract, multiply? Add. So what you're probably going to see here is these are probably going to be combined. 3e to the 1 minus 1 over x. So that's something like it makes sense to me whenever I see somebody tell me how to do that, but something I probably wasn't coming up with on my own. I would probably just panic whenever that extra e was not there for the answer choices. So this is what it would look like. There's a possibility they may even get like denominators there, 3e to the x minus 1 over x. If they do, they could do something like that. You know, make that over 1 and then multiply it by x on top and bottom. Yes, but you need to, yeah. Oh yeah.
Oh
yeah. Wait. Yeah. Right. Right now. Let's try to wait till after that. Although the bathroom might be a safe place to be.
Should I just go hang on to the toilet? You stay in there, like.
Tornado drill is not like a lockdown, so I would say like as soon as you possibly can get back out here to where you're supposed to be.
Well, they say that.
But now if you're
stuff like that, like toilets and stuff like that, are some of the only things like really.
Yeah.
Ground in there.
Yeah.
The bathtub's the best.
Yeah. But like lockdown situation, you would hide because you would. If you could get back to a classroom before they shut their doors, you would try to do that. But if you can't get out here very fast, or you come out here and all the doors are locked, go back to the bathroom and hide the best you can. Yeah, but now tornado drill, it would be okay to join us back because the tornado is not, you know. Yeah, it's not going to, track you down. It's going to destroy us all, so. Yeah. Yeah. So. But. Yeah.
Oh, yeah.
Yeah. Fire drills, you're left in there, which of course for the fire drill you're supposed to try to get out as quickly as you can, so even if you're the last one, try to get out. But alright, so let me go ahead and give you your assignments, which you're probably going to have to crouch in the hallway for a little bit. And I need to print off the little sheet I wanted you guys to get signed for your, which you guys have your first period. You feel okay? You get it? Yeah. So, no, not for that. For your Pi Day shirts. If you plan on wearing a Pi Day shirt, I just want you to get your teachers to initial because I suspect there's been some kids that have been taking their Pi Day shirts off as soon as they left my class and not thoroughly celebrating Pi Day all day. Yeah.
Oh,
so,
but I have to change for PE.
Well, you can change for PE, but ROTC you better have on your Pi Day shirt. Mm-hmm. You know, will y'all change out on an early release? Y'all still change out on those days?
Probably not.
Yeah.
Yeah, as far as that, no.
Yeah. All right, so we are going to do page 391 and 15 through 27 odd, and then 31 and 33. And this will be due Monday.
At this time, a tornado warning has been issued for our area. A tornado warning has been issued. Please, at this time, move to your designated location.
All right, so to the hall.
This hall right here?
Yeah, just right out here outside the lockers. Please be quiet and participate.
appreciate everybody's cooperation. At this time, we are all clear. Everybody can report back to your classroom. Thank you.
Let's see. Several of these, let me just remind you as you look at these, several of these, actually most of these use a Y prime. So like if you're looking at maybe 19 is terrible, let's just separate 19 together. Y times 1 plus X squared, Y prime minus X times 1 minus Y squared equals 0. So Y prime, change that to dy dx. So if we're separating that, what would you do first? Good. So y times 1 plus x squared dy dx equals x times 1 minus y squared. Then I would go ahead and multiply by that dx because it's got to be in the numerator, meaning your x's have got to be on the right hand side, y's on the left. And so over here on the right hand side, you got to get rid of the y, which means you want to take that 1 minus y squared altogether. So you're going to divide by it. And then let me rewrite because it's getting kind of messy. Y times 1 plus x squared over 1 minus y squared equals dy equals x dx. Then what have you got to do? You got to divide by that 1 plus x squared. So we end up with y over 1 minus y squared dy equals x 1 plus x squared dx. It's 19. Yeah. And that's just separating it. So whenever you integrate both sides here, what are you going to have to use to integrate that? Yep, you got to use your U substitution here on both sides. Sometimes you might have to use U substitution on one or the other, but in this case, you got to use U substitution on both sides. And you actually technically should probably use like a U on one side and a Z or K or T or something on the other, so that you're not, so it's not confused, you know, on both sides because they're not the same variable. But you would finish that out. If you want to finish that one, you can, or whatever. Alright, so you've got